So let's take a look at 1.5 inverse functions. And this is a concept that you haven't gone over yet. We're going to take a look at inverse functions. So let's take a look at first the key concepts. Number one, the inverse of a function can be found by interchanging the domain and the range of the function. Remember that domain are all the x values that the picture or that your graph touches, and the range are all the y values that your graph touches. So the inverse would be interchanging your x values and your y values, or your domain and range. Number two, it says the inverse of a function can be found by interchanging the x and y values, or x's and y's, in the equation of the function. So even if they give you an equation, you can find its inverse by interchanging, flipping the x's and the y's. And then it says number three, the graph of x equals f of y is the graph of y equals f of x reflected in the line y equals x. So I'll get back to number three in a second as we do some of the examples, and you'll see why that is. It says the relation is a set of ordered pairs. The inverse of a relation can be found by interchanging the domain and range of the relation. So another way of saying this again. Also, recall that a function is a special type of relationship. For every x value, there can only be one y value. If the inverse of a function, f of x, is also a function, it is called the inverse function of f at x. This inverse function is denoted by f inverse of x. So that's not to the exponent -1, it says f inverse of x. So that's what it's saying here. The notation f inverse of x is read as the inverse of f, or f inverse. Okay, note that the -1 in f inverse is not an exponent, so it's not equal to this in terms of our exponent rules. So let's take a look at example 1. So it's actually pretty simple stuff, finding the inverse, as long as you understand what it means and understand how to take the inverse with practice. So it says, find the inverse of the function below whose ordered pairs are this. So we have a set of 4 ordered pairs. We have an ordered pair -8, 2, 0, -2, 3, 4, and 4, 7. So I'm first going to write it down in a table of values to make it a little easier for you to see. And again, I have -8, 2, 0, -2, 3, 4, and 4, 7. And again, it asks us to come up with the inverse. So this is, for instance, and this would be a function, because for every x value there's only one y value. So I'm going to call this y equals f at x. This is the function y equals f at x. And if I want to come up with the inverse function of this, well, remember what the inverse is. Okay? And the complete definition of inverse is switching or interchanging your x's and your y's. So interchanging your x's and your y's is whatever was an x before is now a y, and whatever was a y before is now an x. Interchanging your x's and your y's. So if I want to come up with the inverse, which is written like this, f inverse of x, the inverse of these ordered pairs are very simple. Again, interchange your x's and your y's. I will do it one point at a time. So interchange my x's and my y's. So the inverse of -8, 2 would be 2, -8. See, your x is 8, that -8, it now becomes your y, and your y was 2, that's now your x. So it's not switching any negative signs to positive signs and all that stuff. It's just basically flipping or switching your x's and your y's. Very simple. So 0, -2, the inverse of 0, -2 is -2, 0. The inverse of 3, 4 is 4, 3. The inverse of 4, 7 is 7, 4. So just completely interchanging your x's and your y's. Whatever was your y before is now your x. Whatever is your x before is now your y. So that is the inverse of that function. Okay? Very simple in terms of just looking at ordered pairs or points. So let's take a look at another example, example 2. It says, find the inverse of the function f at x equals 4x plus 3. And f at x equals 4x plus 3, you should look at this, and you should look at this as a line, because this is the same as writing y equals 4x plus 3. Okay? And that is the exact same as writing y equals 4x plus 3. Instead of f at x, y, it's the same thing. So, again, to find the inverse, this is an equation. It's not just ordered pairs, where you just flip your x's and your y's, or interchange your x's and your y's. This is an equation, and you have to take this equation and come up with the inverse of this. So the inverse equation of this. So if you wanted to come up with that, all you have to do with that, all you have to do is look at the formula and do the exact same thing, which is interchange your x's and your y's. So step 1 would be interchange your x's and your y's. So whatever was a y before is now an x. Wherever you see an x written is now a y. So instead of y equals 4x plus 3, it is now x equals 4y plus 3. Notice wherever I wrote a y, I now write an x. Wherever I wrote an x, I now write a y. And then step 2 is going to be solve for y. So you're going to rewrite it so that y equals everything else again. So solving for y here, I will leave the 4y on this side. So I'm isolating for y. I will bring the 3 to the other side. So this will be x minus 3. And of course, I can divide both sides by 4. So dividing both sides by 4, I'm going to get y equals x minus 3 all over 4. Now, some of you may not like the way this is written. I personally do not like the way this is written, but sometimes in the back of your book that will have it written like that. For me personally, that line there, so that I can see it a little better, I leave the 4y here, I bring the 3 to the other side, which is negative 3, and then instead of thinking of it as dividing both entire sides by 4, I divide everything by 4. So dividing every single thing by 4, I end up with y equals, this will be a quarter x, because there's a 1 in front of the x, minus 3/4. Now the reason I write it like this, and I'll rewrite it so it's y equals a quarter x minus 3/4, the reason I write it like this is because the next question asks me, is the inverse a function? So is the inverse of this line also a function? Because the line is a function. Is the inverse a function? And the answer is yes, because the inverse of a line is actually another line. This is still in the form of y equals mx plus b. The m, or your slope, is a quarter, and your b is negative 3/4. Your y-intercept is negative 3/4. So we are allowed to write this as f inverse of x is equal to a quarter x minus 3/4. Okay? So I'm just going to take a look at this again, and I'm going to show you another way to come up with the inverse of this. Let's say it asks us for a picture of this. A picture of this to start with. And we wanted the inverse of this. Now this is going to go back to number 3 of the key concepts right at the beginning. So let's say it asks us to graph this and graph its inverse. So I'll first graph this thing, and I will graph this in blue. So y equals 4x plus 3. And I'm going to graph this in blue. So I'm going to come up with a table of values for this. And coming up with a table of values, the easiest way for me to come up with a table of values is by looking at the y-intercept. And the y-intercept is 3. Remember, y-intercept happens when x is equal to 0. Okay? So if the y-intercept is 3, the point is 0, 3. And then we can use the slope, right? Your slope, which is rise over run. Okay? So rise over run. And you know that the rise over 1 as a fraction is 4. Well, 4 over 1. So the pattern that this line follows is you are going rise is 4 and run is 1. Remember, rise is up and down, run is left and right. So you're going positive 4, so you're going up 4, and positive 1, so right 1. So up 4, right 1, up 4, right 1. That is the pattern for this line. So my y values are going up by 4s. So this will be 3, 7, going up by another 4, 11, and I can continue that. If I wanted to go backwards, 11, 7, 3, subtract 4, negative 1, subtract 4, negative 5. This is still going up by increments of 4. Okay, so your y's are going up by increments of 4. That is part of your slope. And your run are going up by increments of 1. So I'm just going up by 1s. 1, 2, 3, 4, 5. If I go backwards, negative 1, negative 2. So this would be 5 points for a line of y equals 4x plus 3. So let me just graph that off to the side over here. So if I graph that right over here, and of course if you have a ruler that'd be a little better. Let's extend that just a little bit. Okay, and I will graph this in blue. So the first point is negative 2, negative 5. Negative 2, negative 1, 2, 3, 4, 5. Right here. The next point is negative 1, which is right there. Then I have 0, 3, which is right there. I have 1, 7, which is right here. And then I have 2, 11, which is a little off the page, so I'll leave that one. So if I have a ruler, it should look like this. Y equals 4x plus 3. And that's what it should look like. Okay? Now, if you take a look at number 3 at the key concepts again, if you go up there and you take a look at that, number 3 suggests that when you take the inverse of a function, it is like taking the reflection on the y equals x axis. Now, what is the y equals x axis? If you remember what the line y equals x looks like, the y equals x graph looks like this. I'm drawing a dotted green line. And this is y equals x. This dotted green line here. And y equals x is a line that is 45 degrees. So I apologize, I don't have a ruler, but it's 45 degrees. That is y equals x. And when you take an inverse, it is taking a reflection on this mirror y equals x. So anything on this side of the mirror goes on this side of the mirror when you take the reflection. Anything on this side of the mirror goes on that side. And anything right on the mirror, for instance, negative 1, stays right on the mirror. So let's take a look at that. If I take the inverse of this thing, now I already have all these numbers over here. So if I take the inverse of these points right there, I'm going to take the inverse of these points quickly. So the inverse of these points, so this is y equals the inverse. So the inverse of these points, again, this negative 2, negative 5, the inverse of that point is negative 5, negative 2. The inverse of negative 1 is negative 1, negative 1. The inverse of 0, 3 is 3, 0. The inverse of 1, 7 is 7, 1. The inverse of 2, 11 is 11, 2. So if I go to plot these points now, let's see what happens. Now, let's take a look at what happens to this point. This point, negative 2, negative 5 becomes negative 5, negative 2. So negative 2, negative 5 was here, and now that becomes negative 5, 1, 2, 3, 4, 5, negative 2, 1, 2. So that becomes right here. See, so it was on this side of the mirror, and now it's on that side of the mirror, which is a reflection of the y equals x axis. Then the point, negative 1, 1, becomes the point negative 1, 1. So this point stays the same. Now, why does it stay the same? Because it is right on the mirror. The next point, 0, 3, becomes the point 3, 0. So 0, 3 was here, and now that becomes 3, 0. So that's 1, 2, 3, 0, and it's now right there. So what was on this side of the mirror is now on this side. The next point, 1, 7 becomes 7, 1. So 1, 7, which was up there, becomes 1, 2, 3, 4, 5, 6, 7, 1, which is right here. And so if I draw a line connecting these points here, I end up with a line that looks like this. Again, this is a reflection on the x, or the y equals x axis. Whenever you take an inverse of anything, it is a reflection on the y equals x axis. So whatever blue is on this side of the y equals x is now over here. whatever blue is on this side is now over there when you take the reflection. So that's just a heads up of how your picture will look like of your graphs. So if I erase all this and let's move on to the final examples here. So there's example 3 here. And this is a good one because it's a real life example. I don't think it asks us to graph this, but it says the cost of renting a car for a day is a flat rate of $40 plus a charge of $0.10 or 10 cents per kilometer driven. Let R dollars be the total rental cost and D kilometers be the distance driven. Write a function R of D, rental cost as a function of distance, to represent the total cost of a one-day rental. So let me read it again. The cost of renting a car for a day is a flat rate of $40 plus 10 cents a kilometer. Let R dollars be the total rental cost and D kilometers be the distance driven. Again, write a function R at D. This is rental cost as a function of distance. That's not rental cost times distance. It is rental cost as a function of distance. That just means rental cost, but as a function of distance, one thing, to represent the total cost of a one-day rental. So I want to come up with rental cost as a function of distance driven. So we know for a fact that the rental cost is $40 plus 10 cents a kilometer. So no matter what, it's 40 bucks plus $0.10 per kilometer. So $0.10 times however many kilometers you drive, and the kilometers you drive is D. So $40 no matter what, even if you drove nowhere, and then it's 10 cents a kilometer. Okay? So if I write this proper form, I should rewrite it like this: 0.10D plus 40, so it looks more like linear to me, because lines are written in the form of y equals mx plus b, so y equals your change is, your slope is 10 cents, because for every kilometer you drive, you pay 10 cents more. That's the pattern. And plus $40 flat rate, that's your y-intercept, your starting amount. Okay, so no matter what, even if you drive zero distance, you're getting you're paying $40. Okay, so this is the formula, and it is written in function notation. Very important you get really used to the function notation. And then it says B, find the inverse of the function. So we want to find the inverse of this function. So if we find the inverse of this function, we got to do it using the formula here. Okay, so I'm going to rewrite this formula and just scroll up so that I can come up with the inverse of this thing. And there are a few rules for when you come up with the inverse. Again, rental cost as a function of distance is 1.01D plus 40. Okay, this was our function, our equation. So if we want to come up with the inverse, it's very important that you know what inverse is. Again, inverse is inverting or interchanging your x's and your y's. I don't see x's and my y's, and quite frankly, I don't want you to get confused when you don't see x's and y's and you want to come up with inverse of this thing. The first step when you're dealing with a real life problem like this, the first step will be first writing this as x's and y's. So don't fight me on this, just write x's and y's and this will help you out. So if you write x's and y's, that's the first thing you do. Okay, we'll worry about r's and d's later on. So first write x's and y's only. Now, find the inverse of this thing. What were the steps of finding the inverse again? Step 1 was actually taking the inverse, which is interchanging your x and your y variables. So instead of writing a y, you will write an x, and instead of writing an x, you will now write a y. And then step 2 is solving for y. So if I go to solve for y now, I'm going to end up with, I'm going to leave y alone on this side. I'm going to bring 40 to this side, so this will be x minus 40. And then I'm going to divide out, so I'm just going to rewrite this. And then I'm going to divide out, so I can isolate for y, the 10 cents. So divide every single thing, that's the way I like to think about it, divide every single thing by 0.10. Okay, remember that's a 1 in front of the x. So that will help you out. When I do this, I get y is equal to, and if I do 1 divided by 0.10, I get 10x. And if I do negative 40 divided by 0.10, I get negative 400. Okay, so if I rewrite this properly, I have, I'll just write it this way, y equals 10x minus 400. Now, I'm not going to leave it like this because this is a real life problem. I'm going to write this with the proper variables. Now, it's important you understand that at the beginning, you were given rental cost as a function of distance. That's what you had. You had rental cost as a function of distance, with distances here. If you're taking the inverse is now not rental cost as a function of distance, but rather it is distance as a function of rental cost. So the inverse of rental cost as a function of distance is distance as a function of rental cost. And remember, when you had rental cost as a function of distance, the only thing you saw here was the d, the stuff inside the bracket. So if the inverse is distance as a function of rental cost, the only thing you will see, letter you will see on this side is the r, the thing inside the bracket. So this will be 10 times r minus 400. Okay? So very important that first, so that we don't get confused with r's and d's and all that stuff, the first thing you do is write it as x's and y's. The second thing you do is take the inverse, which is interchange your x's and your y's. Then solve for y. Once you have it isolated for y equals 10x minus 400, then you can talk about putting the actual real letters here, the letters that actually mean something. We were talking about rental cost as a function of distance. The inverse of that would be interchanging those, which is distance as a function of rental cost. So this formula, if I actually had the rental cost, then obviously I can plug in rental cost into this formula and figure out what the distance I traveled was. Question C says, what does the inverse represent? So the inverse obviously represents exactly what I was just speaking about, which is it represents distance as a function of rental cost rather than rental cost as a function of distance. So again, the inverse represents distance as a function of rental cost. So distance as a function of rental cost. Okay? Now, it says here, at the very end, it says, use the inverse function to find the distance that can be driven on $48. So, it's asking us to actually use this function, this inverse, which is distance as a function of rental cost is equal to 10 times rental cost minus 400. It's asking us to use this, so we have to use that in order to figure out how much distance, so find the distance that can be driven on $48. So if the rental cost is $48, how much distance can I drive on that? So distance that can be driven when the rental cost is $48, so I'm plugging in $48 for rental cost, is 10 times 48 minus 400. And so distance driven when the rental cost is 48 is going to be 480 minus 400. And so distance driven when the rental cost is 48 is 80 kilometers. Okay? So this tells you right away that the distance you can drive on $48 is 80 kilometers. Okay? So again, you should understand that inverse is interchanging your x's and your y's, so interchanging your domain and range, your x and your y variables of an equation, or for your points, interchanging your x's and your y's. You should also know that inverse is a reflection on the y equals x axis. Should make sense to you that it's a reflection on the y equals x axis because you are changing your x's and your y's. And obviously in a real life example, if you are talking about rental cost as a function of distance, first make sure you write the equation with x's and y's, and just understand that the inverse, instead of being rental cost as a function of distance, it is now distance as a function of rental cost. And make sure you do your work and practice.
Okay, it says it's right here.
Gee, a real time capsule, eh? I wonder who left it here.
Doesn't say. Here, start digging.
Whoa! Check it out! It's some kind of coded message. Wow! Ooh, wonder what it says. Think it might be a clue to a real treasure?
I don't know, kid, but I have a feeling it is.
But how are we going to solve it? There's no key in the capsule.
Well, it looks like a simple alphabetic shift sequence.
Huh?
Tell you what, let's do the math!
An alpha, who's it? What? Math, huh?
It's a type of coding that deals with the relation of letters. A relation is a pairing of elements of one set to those of another, making a set of ordered pairs.
Huh?
We think of these ordered pairs in terms of input and output. Now take schools and their mascots, for instance. There are several schools, and each one has a mascot.
Sure.
The schools represent our input value, and we call this the domain. The mascots represent the output, and we call this the range.
Okay.
This is a function because for every school, the input, there is only one mascot, the output.
Got it.
The reverse is not a function because a mascot can go to many schools. Now this is what we call the inverse of a function.
Okay. But how do we use that to decode the message?
Well, now you said there wasn't a key to the code, but there is.
Huh?
You see that function there?
Yeah?
That's your key right there.
It is?
It's telling you how to put together a table of values that they use to encode the message. Now you would read this by saying f of a is equal to d.
F of A is equal...
Generally, a function is written f of x equals y. So if your input is the x column and the output is the y column...
Wait! So for the function they use to make the code, A is equal to D? Is that what that means?
Well, technically A is mapped to D, but yeah, you got it, kid.
So that would mean that B is mapped to E and so on.
Yep. Better yet, what you're doing is building a list of ordered pairs for the code, which translates to a bunch of XY coordinates that can be plotted on a graph. Notice on this graph that for each letter on the horizontal or x-axis, there is only one letter on the vertical or y-axis that corresponds to it. Now you can actually test for a function this way. If we draw a vertical line through any part of the graph and it intersects the graph at no more than one point, we have a function.
We do.
This way, we know that they didn't have two possible letters to represent the one they were trying to encode. So, each letter in the domain is mapped to a unique letter in the range. Now, in this case, each letter can be mapped back to a unique letter in the domain.
Oh.
So, with that in mind, the inverse is also a function.
Cool. So, all of what you just said means I have a way to decipher the message. And my decoder key is F inverse of D equals A?
You make me so proud, boy.
Oh, please. So the first letter is O, which maps to L. The second letter is H. That maps to E.
You got it, kid. Now keep going.
Oh, this is fun. Okay, let's...
do the math!
What? Let's do the math? Really? Math? That's the crummy message?
Hey, what else is in there? Oh, so that's where I put that mug.
You put this here, didn't you?
Well, yeah, I thought you might like the challenge of finding it.
Oh, man.
And, learning about functions and such.
You have got to be the most dysfunctional ghost I ever met. You need a hobby.
How about singing? Home, home on the range, where the deer...
You are not a cowboy.
Deer,
or a singer. Or a cello player.